What's going on? Sean, the Master Tutoring here. And in this video, we're going to talk about the extreme value theorem. Make sure you like and subscribe. Um, and let's get into it. All right, so I'm going to write a few things here. This is probably going to be a pretty short video. Um, but here we go. So if f is continuous on closed interval rather, a, b, then f attains an absolute max which we'll call f of c, and an absolute min fd at some values c and d. All right, so let's read that again. So the extreme value theorem is this. If f, you have some function f and it's continuous, that means it exists at every point in this particular interval between a and b, closed interval, then f attains an absolute max, which will be fc at point c, and an absolute minimum f of d at point d. Okay, so basically it's saying that there's going to be maxes and mins are what you would call extreme values, hills and valleys. Okay, and so that's in a nutshell what this states. Okay, now another thing to mention is the word absolute. If it's absolute, that means it's like the highest max. Absolute min is like the lowest minimum. Now, a couple of points to add here. It's supposed to be an arrow. A couple of points to add are that extreme values can repeat. That means you can have like two maxes or two mins at the same level. And then also, um, endpoints can be extreme values. What I mean by that is on that interval that goes from A to B, A or B themselves could be points where you have extreme value. So let's kind of just illustrate this with a few graphs here so we can kind of get like a mental picture, if you will, of what these might look like. So say that you have the following. So say you have, let me change some color here. So this graph looks like so. I probably should have extended that, but that's okay. This next one is like this. And then this one looks like that. Okay. Now let's label. So here our interval goes from A to B, A to B here, and then A to B here. All right, good. So looking at this first graph, we have here somewhere in here, point C, we have our extreme value of maximum at f of c. And then somewhere in here, D, we have f of d, which is our minimum, if you will, absolute minimum. Okay, I didn't draw that very well, but that's supposed to be the lowest point. Okay, now if you look at this graph, we obviously have a maximum here, FC at point C. In this case, B is equal to D. This is where our minimum is right here. And it's at an endpoint, you see? And then finally, this illustrates what we said here. You have a absolute minimum here. But then if you look, you have what we'll call C1, C2, C1. So F of C1 is equal to F of C2. These are the same value. They're at the same height. So this is just an illustration of when I'm sorry, I meant to say that this matches the first uh sub point that I made, that you have repeating extreme values. Okay, so this in a nutshell is the extreme value theorem. You want to watch my Fermat's theorem video after this, so I'll make sure I have that as a suggested video after this, to take this concept further. Let me know if this is helpful, and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.